All right. Harmonics is the study of oscillation. So that has to do with sound waves, some yes, music, waves with water, but it also has to do with bouncing springs. So if you attach a ball to the end of a spring, pull it down and let go and watch it bounce up and down, that's also harmonics. There are lots of different types of harmonics. We are not going to get that far into it, but wherever you go into physics, which harmonics is a field of physics, there are different types of harmonics. We are going to do very, very, very simplistic harmonics. And we're going to do so simplistic that it is not even funny.
So is it a break?
Huh?
All this like a break?
Sure, yes, yes. I mean, it is very simple. We're doing this to show you kind of an application of sine and cosine. All right, so this is kind of your simple harmonic functions. We have this one and we have this one.
What's the difference?
One has sine and one has cosine. D stands for displacement. Whenever you're looking at a wave, D would be displacement, so it's the distance away from that center. Yeah, because D could also be here. That could also be D. So D is the same as your Y value whenever we were doing this. A would be your amplitude. So remember, amplitude is your highest or your lowest point. So it's that distance there. So yes, up here, that's kind of the highest point, so I could let that be A. T, whenever we're doing this, T is time, primarily in seconds. I think everything we're doing today is in seconds. Displacement will change depending on what they want to give you. It could be in inches or centimeters or whatever. So that's why I didn't put a unit with that one. Omega, which that's a small w, sort of, but it's actually supposed to be the Greek letter omega. Has to do, just like whenever we were graphing, it had to do with period. Period equaled 2 pi over omega. And then we're also going to talk about frequency. Frequency is omega divided by 2 pi. Period and frequency are reciprocals of each other. No, it's just a number. So frequency equals 1 over the period, or period equals 1 over the frequency. Period, remember, was how stretched out our wave was. Frequency, what that does is we count in 1 second how many waves go past. That's the meaning behind frequency.
And the meaning behind period?
Is the length of the wave. Okay, so this is the meaning behind everything we have here. I don't think there was anything else I wanted to say there, but let me make sure that I'm not missing anything. No, I think that's it. Remember, amplitude is always a positive number, so I could put absolute value sign on that. But again, we're keeping this very, very simple. Okay. So, let me show you what your problems are going to look like. Your first type of problem, what they're going to do is they're going to give you some information and ask you to write the equation. The first thing you have to do is decide whether you have sine or cosine. This first statement will tell you that. Hey, so you have to, what we do is we use the concept that you had whenever you were graphing. Remember, the graph of sine started like this. The graph of cosine started like this, correct? Okay, so this says that t equals 0. So t is kind of in the place of x. At t equals 0, the displacement is 4. So this gives you an ordered pair of 0, 4. So that means it would have to be cosine. So this first statement is either going to give you an ordered pair of something like 0, 4, or it's going to give you an ordered pair of 0, 0. If it gives you an ordered pair of 0, 0, that would mean sine. If it gives you an ordered pair of 0, and another number, that's going to mean cosine. It would always be 0 because they're always going to tell you t equals 0.
Where did the 0, 4 came from? Like, what is that, like, an x, y,
T equals 0. That's your x value. Because your order pairs in this look like this, TD. And then they tell you that the displacement equals 4, so that's your D. With this first statement, if you get an ordered pair that's 0, 0, that means you have sine. Because your sine graph always starts at 0, 0. If you get an ordered pair that looks like 0 and then another number, that's going to be cosine, because cosine always started at the top of a function. Okay, so that means we have this, and we need to fill in those other two numbers. Okay, so what's our amplitude? Our amplitude is 4, so that just means I need to fill in the 4 for A. Period takes a little bit of work, because my equation for that is P equals 2 pi over omega, and omega is the one that goes into this spot. So they give you 3. You need to figure out what omega is. So that would be 3 omega equals 2 pi. So omega equals 2 pi over 3. That would be your answer. That's it. All you're doing is finding the equation. They give you the information. This is here's the equivalent problems in the book. Huh? Only those 4. Well, then we have example 2. So example 2 gives you the equation and asks you to find some information from the equation. So, maximum displacement. Maximum displacement means what? Amplitude. This means amplitude. So for A, what is the maximum displacement? 1/2. Let me see if they give units on this. I don't think they do, so all you can do is give 1/2. Okay, frequency. Well, formula for frequency is omega over 2 pi. So that would be 4 pi divided by 2 pi. So my frequency is 2. That means 2 waves go by in 1 second. Okay, value of D when t equals 5. So D equals 1/2 sine of 4 pi times 5. So sine of 20 pi. Okay, what is 20 pi? If you go around your circle, 20 pi is going to end up being in the same place as what? As, 0. So what's sine of 0? 0. So 1/2 times 0 is 0. Yeah. Sine of 20 pi is 0. Because on your unit circle, 20 pi is in the exact same spot as 0. There. 2 pi, 4 pi, 8, 10, 12, 14, 16, 18, 20 pi. Sine is the y value, so the y value is 0. So sine of 20 pi is 0. So then 1/2 times 0 is 0. Basically, any even number of pi is 0. Any odd number of pi is 0. Any whole number of pi of sine is 0. Okay, this one takes a little bit more work. Least positive value of t where d equals 0. Okay, well, so we need to put that in. So d equals 0. Okay, so I can get rid of the 1/2. If I divide that off, that still equals 0. Okay, I want the first positive place. So 0 doesn't work. I know that sine equals 0 at 0, correct? But that's not positive. So where's the first positive place where sine equals 0? So if I go around here, the first positive place would be pi. Correct? You all right with that? So, first positive place is pi. That gets rid of my sine. Now I need to finish solving that though. How did I get rid of the what? I just divided it off. Okay, so my next step would be to divide both sides by 4 pi.
Why did you put 0 with pi?
On my unit circle, I want to find the first place where sine equals 0. That's positive. So, as I go, sine is the y value. So where's the first place where the y value equals 0? It'd be right here. So that's at pi. So that's how I got rid of the sine. So the first positive value would be 1/4 of a second. Okay, so that's what your problems look like. How did I do what? I divided it. So here, or you can multiply by 2. So I can take both sides times 2. Well, you're multiplying the whole thing. But you only multiply once, so this cancels out, so it's gone. Then to get rid of this sign here on this step, I use my unit circle. And then here what I'm doing is I divide both sides by 4 pi. Okay, so now there's only like 4 problems in each section, so and then there's 2 story problems. The story problems are the same thing, but I wanted to give you the story problems too, so you have like 10 problems. But I just wanted you to see the story problems. You'll have one problem like this on the quiz and the test, but your quiz and your test problems will look like example 1 or example 2. It will not be a story problem.